Hey guys, it's only 7 of you. How do today, you know, good?
Yes, sir.
Good evening, sir.
Hello?
Yes, sir.
Understand. When you come in the class, you need some minutes to see if the others will join. And then because we're starting something new today, we've completed McLaren's, sorry, not McLaren's, Newton Rampson. And now I do not one more question on Newton Rampson. We overspend our time on Newton Rampson. What I want to do today is to move into some McLaren logarithmic functions, exponential functions, and yeah, so one of the things that I thought about today was whether or not I should do a review of the differentiation, but because I overspent my time doing Newton Rampson, I may not have that time to the luxury to sit down and to go through that sort of exercise with you. So trust me, when I get back, I'm going to just present you with the McLarens. Hopefully the experience in doing our differentiation is a little worthwhile, so to speak. All right, yeah, so I was going to give you something to do for now, but let me just wait and see if those who may join, I'll come back to you in another couple of minutes, all right? But just think about it. We're doing differentiation, and more differentiation. So what it is that we're doing is applications to differentiation. So Newton-Raphson is an application to differentiation. Remember, for Newton-Raphson, we had to differentiate the function. For Maclaren's expansion now, is that we are going to be doing the same thing. So it's lots and lots of differentiation because we're looking at the applications. All right, so in order for you, I will come in and we can start. Please, I really want you guys to speed up this learning process and not spending 2-3 weeks on this. All right, soon come.
All right, sir.
Okay, sir.
Go ahead. Hello? You're saying something?
No, sir. I just said, okay, sir.
Oh, okay, good. Please. All right, guys. I'm only seeing 9 of you here. All right. Do me a favor. I want you to differentiate something for me. I'm going to give you a function and I'm going to ask you to differentiate it 5 times for me. And then we're going to have our conversation on it. Are you hearing me?
Yes, sir.
Okay. So I'm going to give you the function now. It is gonna be any minimum anymore. All right, let me give it that. 1 over x plus 1. 1 over x plus 1. And I want you to differentiate that 5 different times for me. 5 different times. So you're going to differentiate it once, get the answer, you're going to differentiate it again, get the answer, differentiate it another time, and you're going to do this 5 times for me, please. 1 over x plus 1. Understood?
Yes.
All right, thank you. Yes, Papa. All right, so how far are we? Have we completed the first differential yet? Second one, third one?
Sir,
Yeah.
sir, I had to start over. I don't even know.
Okay. Anybody has completed the stuff? Somebody talk to me now, man. Somebody answer me, please.
Sorry, all right. No, sorry. It confused me a little.
All right, cool. Take your time.
There. Sir. No.
Hearing you. I'm hearing you. Go ahead.
All right, sir. Before
I'm hearing you. Go ahead.
yeah, me I say me no want to continue with the foolishness with me, I do, sir. So I tell you what me have. Yeah, the first was 1 over x plus 1, right?
Yeah.
All right. All right. So what me have is that me know remember say if you have 1 over x plus 1, that can also be written as x plus 1 to the minus 4 the minus 1.
Mm-hmm.
All right. So if we differentiate that, we'll get -1, -1, x plus 1 to the -2. All right. So recess or no?
No,
No?
no, no,
Yeah?
you're not finished yet.
You not finish
Because
it?
that would be part of the power rule. So you know how to differentiate what is on in. No, you have to differentiate what is inside the parentheses. No.
Oh, hold on. Differentiate.
I mean, to recall the power rule, sir.
No, not the power rule. You remember what he was saying is that he used the -1, brought it down, differentiated the stuff, and came to the -2. But I was saying to him that he now needs to differentiate what is inside the parentheses.
Okay.
Sir, so that may I say, when you differentiate the function there, you're gonna get -1 x plus 1 to the -2 if you differentiate the function. No?
Yeah, yes, but you're not finished yet. That's what I'm saying. You now have to differentiate what is inside the parentheses. What is inside the parentheses? Say x plus 1.
Yeah, the x plus 1.
Say no. Right. So you have
X.
to differentiate what is inside the parentheses. What is inside the good. I mean, you differentiate x to get what? So
1.
on.
1.
Right. So you have to times it by 1.
Hold on this work. Make me slightly about my brain. When we break down, when we differentiate the x plus 1 to the -1, right? So you're saying differentiate what is on the outside times what is on the. Okay.
The power rule says you now have to differentiate what is inside the parentheses, the x plus 1. Now, you will know that differentiating x plus 1, you're going to get 1. So it really doesn't change. It doesn't change what it is that you have there. But I want to tell you from now that you have to differentiate inside, because I could have given you a function 1/2x plus 1. And that will make a difference because the differential of 2x plus 1 now will be 2.
Cool.
And 2 is going to be a different number than 1. 2 will make a difference. Is what I'm saying, utterly?
Yeah.
Sir,
Okay,
beg you, sir, you can do me a favor.
So you have to go ahead.
I beg you a favor, sir. You're not on a whiteboard.
Go ahead.
You're not on a whiteboard, sir.
I do. I do.
We're trying by power. That's weird. You're trying by power rule, sir. Hold on there.
Let me
mix up the power with product.
all right, let me give you another example. Let me give you another example. What is this? Okay. I want you to look at example number 4.
All right.
Because we're going to be doing the logarithmic function as I just told you. So let us look at example number 4. It says y equals ln 2x plus 3. Hold on 1 minute, please. Hold on 1 minute, please. All right. Are you seeing the screen? Are you seeing the screen, Bijan?
Yes, sir. Yes, sir.
All right. Now, I want
Sorry,
you to work with me, and the rest of you too, because
sorry for
say
interrupting,
something.
sir. I just came back, sir. So
Go ahead. Yeah, man. So we're just refreshing something, CrossFit.
okay. So this is the power rule, right?
Yeah. I'm trying to give me half a second. I'm trying to connect to 2 different devices. Should in case one goes down. At least I'm still connected. All right. All right. You can still see my screen, right?
Yes, sir. Yes, sir.
All right, good. Okay. It's a good thing I did what I did. Something is reconnecting. I think I've learned my lesson to connect to 2 different devices. All right, so the screen should be back up. Let me know if you're seeing it, please.
Yes, sir.
All right. So you have y is equal to ln 2x plus 1 or cube. Once you have a set of parentheses raised to a power greater than 1, you have the power rule. You have the power rule. All right. Now look at what is going to be critical. And this is me refreshing your memories, because I would have done the logarithmic function with you from calculus 1. And whether or not I taught you calculus 1, you would have completed the logarithmic function. So this is really a refresher. So when I'm differentiating the logarithmic function, the differential of the logarithmic function is 1 over the function times the differential of the function. So the differential of the logarithmic function is 1 over the function times the differential of the function. Look, 2x plus 1 to the 3rd power. When I'm differentiating the logarithmic function, it's going to be 1 over the function. See here, have it? 1 over all of this, 2x plus 1 to the 3rd.
All right.
So when I'm differentiating the logarithmic function, it is always 1 over the function times the differential of the function. So it is going to be 1 over the 2x plus 1 to the 3rd. See it right here. So all of this. Now I need to differentiate the function. So this is a part of it that I was talking to you about, Bijan. So in differentiating 2x plus 1 to the 3rd power, it's going to be this 3 in front of the parentheses times 2x plus 1 to the 2nd power. And then now I must differentiate what is inside the parentheses. So in the question I just gave you, it was x plus 1. But I'm saying to you, let us get into the habit. Good, let us develop good habits from day 1. Even though it is x plus 1, there will come a time when the function is not x plus 1. It's going to be something that is and I don't want you not to remember how to do the differential of that on the inside. Right? So you have to differentiate what is inside there. So it's going to be times the differential of what is on the inside, which is going to be 2. So this question now, in continuing, this question is going to be 3 times 2 is 6. And see the 6 right here?
I don't understand where we get the 2 at the end.
The differential of what is on the inside of the parentheses.
Oh, so that would be expressive.
Okay.
So remember, the power rule says that I'm going to differentiate the function as a whole, but I also have to differentiate what is inside the parentheses.
Okay.
Yeah, yeah.
You follow what I'm saying? Was that Chanel a while ago?
Yes, sir. Yes, I get it.
Right. So you have to differentiate what is inside the parentheses. So watch me. 3 times 2 is this 6. And this 2x plus 1 all square. See here? 2x plus 1 all square. And this 2x plus 1 to the third power is all of this. 2x plus 1 squared times 2x plus 1. So I have 2x plus 1 to the third. I only wrote it like this here because I want to show you that this 2x plus 1 all squared cancels out. So I'm going to be left with 6 over 2x plus 1. I'm going to be left with 6 over 2x plus 1, and that's my answer right here. So let me ask you there any questions.
Yes, sir. Remember question.
Go ahead.
I know about this though, sir. Sir, you said I'm to visit the YouTube for the class I missed on Wednesday. I didn't see it on the YouTube.
Have you seen any of them at all?
Yeah, man, I'm seeing them, but I didn't see the last class.
And go back and check.
Okay, we get that.
I'll go back and check for you.
Yes, sir.
But Chanel, that kind of random still, you know, but if you ever ask one question, but when we just ask you a while ago.
No, man, so that's why I'm going to tell you, say it's not about this, sir. Sorry.
All right.
So you
my
factor
question-
out the denominator, you factor out the denominator in order to try cancel.
Very good. Very good. Excellent. Very good. Very good. I want you to tell me that you understand this so I can move into another question so that you can see how the calculations are done.
I know.
Remember. Okay, nice, National. You remember the application questions, that we're looking at here assumes that you know how to differentiate. Application questions here assume that you know how to differentiate. Right? Application questions assume that you know how to differentiate. So if you don't know how to differentiate, ouch. Herein lies the problem.
No, I just never remember that power bit.
And I got you perfectly. All right. So let's go now. So since there are no questions there, let us look at. Go ahead.
Sir, you're going to like the question that you just gave us, right?
Yes, Joe.
Okay, I just making sure because it kind of confused me at the step of the.
Yeah, but that one kind of random. So still, your question and Chanel question is kind of random still. So yes, I am going to do that. But what I want you to do for me first is just a quick refresher that you understand. Remember how to do the differentiation. So we have done the logarithmic function before. The differential of the logarithmic function. We've done that before. So what I want you to do for me now is to look at question 5 that I have projected on screen. I'm going to look at question 5. I have blocked out the answer, so to speak. Let me put the question up somewhat because I know somebody can say, sir, I can't see the question properly. I have blocked out.
Oh, we do number 5.
I want you to do number 5 first, and then know when we get. Oh Lord. When we get to a little bit more into understanding what is happening, I'll go back to the question I just gave you. So let me try and
Okay, past
find.
5.
No, that
What?
was 5 for the exponential function. I'm looking at the log. See here, right here.
Yeah.
Obviously.
Sir, may I work on?
All right, we're good.
Sorry, this we did in a class last week. I never get the recording, like I said.
No, we continued with Newton-Raphson last week, and we finished Newton-Raphson. So we're starting this for the first time today.
Sorry, you can times one constant by 3x squared.
If you can times a constant by 3x squared.
Mm-hmm.
Oh, yeah, ask Vision if a 6x square you're gonna get.
Yeah.
Yeah.
All right, that's how I'm. See, what on the song that class, one of my teamwork, make it dream work, man. They have man a struggle.
Vision, they agree with you here.
Hmm.
You see, you can't call upon courage this time because courage is not traffic. You understand? Like you did last week. But the rest of them don't sit down there. Lotto, where are you, Lotto? Are you in traffic or are you at home or are you at work? Which one, Lotto?
I just land.
Me know, because from me no hear you say nothing, me know say something else. Are you there eat ackee? Which one?
No, just land, sir. Just land. I try.
All right then. All right then. Come on. All right. Go on work.
She know I get 6x over 3x squared minus 5.
Well, on there.
That me having a
So 2 person have the same answer. So scroll up now, say.
So don't put up in a paper. Then.
Yes, I get it.
Let's say you get shit.
What's mine, right? We get 6x squared over x cubed minus 5.
Yeah, man,
Same.
that's what I get,
Same.
man.
Oh, okay.
Dan, I hear you try to come in. What's up?
Who, me, sir?
Yeah. You're trying to say. Oh, sorry, Tash. You're trying to say something here.
Oh no, I've said I got the same answer as them.
Oh, okay, good. So then I talk about. I'm gonna make vision. I can load up in the class. The talk about the man.
No,
Evening,
sir.
sir.
My maneuver around 3 different books. That's why. So.
Oh, all right then. Cool.
Evening, sir. Just joining.
All right. Easy puppy. Nice.
Sir,
Yes, please. Go ahead, Joe. All right, let's go. So am I to assume that you all finished the question?
You're talking number 5, sir?
Okay. Go again, Crosswell.
Yeah, I was asking if you're talking number 5.
Yeah. Number 5. You finish it, Crosswell?
I'm doing it right now, sir. That's what I ask.
Oh, all right. Okay, hurry up. Vision, you finish your question now, Pops?
Yeah, well, sir, shall we get the same answer? So I will be right.
Yeah, say your answer again.
6x squared over 2x minus 5.
sir, I heard what I said.
And 2x
You said
cubed,
Joe.
x cubed minus 5.
X cubed minus 5. Okay.
Same answer me after, sir.
Sir, I mean one never get none of them answer.
We don't know if you're right yet. Here we are.
And for me, I have to.
What did you guys get? 3x?
Tony, Tony.
6x squared over
X cube plus
3 cubed. X
Sir,
cubed.
I got 2 over x cubed minus
Tony,
5.
I was just about to say something to you, Tony, to say, why Tony does not deal with me right at all. Me not here for an hour and then I saw an answer. All right. Let us check to see if you guys are correct. And if not, we're just going to call it a night and we just
No, call it a night, sir. What can I stand on?
No, we're right.
Yeah, man, right, man.
All right, not bad.
very nice, very nice. Jojo, what you get for the answer?
Sir, you never hear me sing my answer how long? Sir, I get 2 over x cubed minus 5.
How you go with that?
Sir?
So you go with
Never
that?
differentiate when at the bracket. And that's
Sir, do you know?
She did not differentiate what is inside the parentheses. Yes. You're
Yeah,
missing a
that me never
3x
do.
squared. You say you get
Yeah.
2
Sir, I
over
have the
x.
2 sir, where I have the 3x squared, I have 1.
I'm like seriously? So when you differentiate x, you begin get 1. Mute phone. Mute the device. I'm gonna fix me something.
Sir, I fix it.
So
Okay.
I don't know the denominator right there. An issue right there.
You have an issue here. What issue you have?
No, sir, I have the 6x squared. X cubed minus 5. I know that was an answer. Right there. I didn't get to finish for the answer. That's right there.
Sir.
Yes, please.
All right, sir. I am asking if you can just quickly explain what number 4. We can get on track.
Yeah, okay.
All right, no problem. Number 4 is the same thing as number 5. What it is that we're looking at is just a refresher of the differential of the logarithmic function. So what we're doing is, because we're moving into a new topic and application to differentiation. So the premise is that we're come to calculus 2 with our differentiation right up there, right this up. So what we're doing is to just do that refresher. So what I did in 4 is exactly what it is that we looked at in 5. So 4 is just one example, 5 is the other example, and then I'm going to round it off now with question 6. So let us go back to my question 5. So look at the explanation to 5, Mikey, and you'll catch what 4 is saying. And then I'm going to give you one more before we move back to McLaren's. Very important. How did we get here? We got here because I wanted to show you how to refresh your memories on the differential of the power
Hold
rule.
on there. Sorry, you just said go back to McLaren. We start McLaren's last week?
No.
Oh,
Today.
so I go back.
Yeah, man, go back. Yeah, I started McLaren's. I gave you something to do 1 over x plus 1. That's McLaren's expansion.
Oh,
So we
sorry.
started McLaren's today.
Since this class start, you do that.
Yeah, since this class, yeah.
Oh,
But
my
I
job.
paused because people didn't recognize, didn't remember rather how to do the stuff. So I just pause it and then I'm doing some refresher. All right, let's go. Let's go. Let's go. Let's go. Let's go. All right. So ln x cubed minus 5 all square, find dy by dx.
Sorry, so question. I still unit 1 this, right?
The differential of the function. See it again.
Sorry, what question do you say I make to do?
Can
Question.
you give us a question because my internet a break up?
They ask what to. Sir, gone. Who get the question? Share it, please.
No, and you say me that explain
It was
this,
not yet
let's just
shared.
reach it. So I explain that to the person and then him go to the next question.
Oh, got you, got you. Thanks.
Otterly, are you hearing me?
Thanks, John.
You're just coming back, sir.
Oh, okay. All right. All right. Let me reshare this stuff. Let me know when you see the screen.
Last week, sir.
Yes, sir, we're seeing it.
See the screen?
Yes, sir.
Yes, sir. I've seen the screen.
All right. All right. I'm hearing you, but the screen soon stop sharing because it's reconnecting. Is it back up for you?
Yes, sir.
All right, good. All right. So what I'm saying to you is y is equal to ln x cubed minus 5 all square. And they're asking us to find dy by dx. The differential of the logarithmic function is going to be 1 over the function times the differential of the function. The differential of the logarithmic function is 1 over the function times the differential of the function. So it's going to be 1 over x cubed minus 5 all square. See it right here, so? Times now the differential of the function. So I'm now times by the differential of x cubed minus 5 all square. In essence, that's the power rule. How do you identify the power rule? You have your parentheses raised to a power that is greater than 1. Raised to a power greater than 1. Watch me. I'm differentiating x cubed minus 5 all square. You're taking the 2 in front. See it right up here, so? Then reducing the parentheses by 1, the power by 1. So it's going to make x cubed minus 5 to the first power. But what is important, you must differentiate what is contained in the parentheses. You must differentiate what is contained in the parentheses. You cannot not differentiate it. You must differentiate. So when you differentiate x cubed minus 5, the differential of a constant is 0, but the differential of x cubed is going to be 3x squared. Agreed?
Yes, sir.
All right. And that's how I end up with this 3x squared right here. And then, what I'm going to do is to multiply this 2 by this 3x squared. That will give me 6x squared. And of course, I'm still going to have this x cubed minus 5 to the first power. And all of this 6x squared times x cubed minus 5 to the first power is going to be sitting at like here. So what I did, like I did in the last question, was to break up the x cubed minus 5 all squared into x cubed minus 5 times x cubed minus 5. One of those cancel. So I'm going to be left with 6x squared over x cubed minus 5. Mike, you see that?
Yes, sir, I get it.
Yes. All right. Final one, and then we'll move back to Clarence.
Sir, got the answer already.
Good job. Nice job. I have to get in a McLaren, a full question of McLaren before we go. So try that one for me, please.
So I just came back, my internet kicked me out, I had to relocate.
Yeah, man, trust me, I have been having a challenge with the internet business from last week, well, even before. It is, oh.
I don't know what is happening, sir, because normally I sit down upstairs and do my work, and now I have to relocate, like the internet get weak, I don't know what's happening.
Yeah, well, you're the computer people, so they're supposed to can tell me what going on, because in my class on Saturday, it just, goodness, it cut off. It just go, and it's not just the digital Wi-Fi, the flow Wi-Fi to have been speaking. The two of them. All right.
Where to do this question?
Number 6. I want you to try number 6 for me.
Okay.
And that's the last one, and then we'll go back to McLaren's. All right. I give you 2 minutes.
Finished, sir.
Very good, Courage. All right. Hold on to your answer a little bit. Let me give those another minute to finish off. Very good, sweetie.
So if you give an exam, all right, to the power of 1, you're not going to write mark it down for that.
No, man, I wouldn't.
All right.
Okay, Crossy, I've seen your response.
Sir. Mr. Mark?
Yes, Crossy.
Now say, could you go back to number 4?
To number 4, sure.
Yeah, number 4. All right then, sir.
No problem. The rest of us, are we finished?
Yes, sir.
Yes, sir. I send my answer.
Yes, sir.
Ah. Okay. I think I know what happened. That's what I get for the answer. That's what you got?
Sir, where's the answer?
Is the answer, sir?
6 over x squared minus 5.
Yes, sir. That's what I got.
That's my answer.
Somebody talk to me.
Yes, sir. That's what I got.
Yes, sir, we're talking to
Yes,
you.
sir, same answer.
Yes, sir.
That's what we got, sir. Sir, still here?
My answer is wrong, so but we see the correction. Where I went wrong.
Sir?
Sir, not here.
Sir, you're kind of low.
Are you hearing me better now, guys?
Yeah.
Right here, yes, sir.
Okay, great. Thanks. All right. So I want to get the tail part of what you're saying, Lotto. You say you got the answer, right?
Yes, sir, we got the answer.
All right, nice. Did anybody else? Yeah. Anybody in the class got something different from what I have?
Yes, that was what I was saying. I got it wrong, sir, but I saw where I went wrong.
Tell me where you went wrong. Talk me through what it is that you did.
It didn't bring the square. So when you have the first line dy over dx equal 1 over x squared minus 5 cube times 3, then you have the x squared minus 5. I didn't put the square. So I just left it by itself, not realizing that differentiation went on. So I should have minus and have the square at the top. So it went from cube to square. Yeah.
The square.
You understand what I mean, sir? I mean,
Happy that you see your.
There.
Say it again, sorry?
No, I was wondering if you understand what I said, because I said a lot of things just now.
Yeah. Come on, I follow you.
Okay.
I follow you. All right, so I'm moving back to Maclaurin. So you see on the screen now it says Maclaurin's theorem for approximating functions with infinite series. So we're going to be looking at Maclaurin's. Even though I gave you something to do, let me just, time is running, let me just go ahead with the introduction to this and then leave you to complete that one for me for class tomorrow, God's willing. So I want you to look at the function in pink. Function in pink says, or the equation, f of x, when you do your expansion, and remember, no, this is an infinite series, so it go along without no end. So a question like this, so some functions, when you differentiate it, you get a finite number of terms. But there are other functions, when you differentiate, you will end up with an infinite number of.
Sir?
Yeah, one more question, one working on top question.
Are you hearing me, guys?
Hearing you now,
Sir,
sir, you
no, I
cut out
hear
for
you.
a minute.
Yeah, it keeps reconnecting. Sorry about that. I really apologize. Keeps reconnecting. All right. So what I'm saying to you, I was explaining. Maybe start again. I don't know how much you've heard. I was saying to you, when we're looking at the Maclaurin's series, it speaks to approximating functions with an infinite series. An infinite versus finite. Some functions, when you differentiate, you get a finite number of terms, whereas other functions, when you differentiate, you get an infinite number of terms. Now, allow me to help you to understand what I just said. So a finite number of terms are those terms that you can count. So sometimes I'm differentiating a function and I can get only 3 terms because the other terms when I differentiate will be 0. But an infinite number of terms, it means that I can differentiate and differentiate and differentiate, and it never gets stale. It never gets stale because I'll always have a function to differentiate. So it's going to be when I would have performed the differentials, if you look into the formula, you can see f dash. F single dash is the first differential. F double dash is the second differential. X triple dash is a third differential, and so forth and so on. So look at the function in pink for me. And where you see f dash of x is the first differential with respect to x. F double dash of x is the second differential with respect to x. F triple dash of x is a third differential with respect to x.
Sir, I say we now get the formula when we do the exam.
No, I can't close to that, you know.
What is that supposed to mean, sir?
But then I get the formula.
But if we never get the calculus one, when Sarah said about the calculus,
Yeah,
we
but
should be
Talk truth. If we never get the for calculus one, how you expect we get the for calculus two?
Sir, we never do face-to-face exam for calculus 1.
School that.
That's why I'm ask. This school,
Right.
Sorry? I feel like we lost somewhere.
All right, don't worry about it. Don't worry about what you said. So the answer to our question is no. We ain't getting the formulas. It's going to be something that you have to be able to remember. But it's not difficult to remember because I'm sure the same question was asked of me when we looked at Newton-Raphson. Does anybody know the formula for Newton-Raphson without looking back?
Sir, if I had the answer, I would be lying because I just looked back.
Thanks for your honesty. I'm
combined,
told you.
sir. X1 minus f of x over f of x in inverse.
No, the differential.
So differential.
Right, right. So the point is, when we would have worked with many questions and applying the formulas for these many questions, it is hoped that the formulas will stick. So you have to do the questions in order for the formulas to stick.
This look complex though.
No, man, it's not complex. It's not complex. Let me tell you how easy it is. You see where you say f dash of x is the first differential. And on the f dash of x, you can have 1 with an exclamation sign. But in this case, I didn't write the exclamation sign because one exclamation sign is just 1. And I'll explain that. Look under f double dash of x. F double dash of x has a 2 with an exclamation mark on it. True or false?
Sure, true.
Yeah, man. F triple dash has 3 with an exclamation mark underneath it, don't?
So that the slash in terms of differentiation.
Yeah. So let me ask you, what is f to the 10th differential of x supposed to be divided by?
110.
Sir, 10.
Just 10 alone? So.
10. What is that?
Sir, 10 with the exclamation mark.
Exclamation mark.
0 over 10 to the exclamation.
No, what is that symbol they call it, sir?
10 with the S. Right.
Plural.
10 with the
10 with the excitement.
Don't worry about this. I
Sir,
soon tell you.
sir, I have a
I'm tell
No,
you.
what's the name of the term,
I
sir?
soon tell you what it is.
Sir, I have
I
a
soon tell you what.
question.
Yeah, me soon tell you what. I'm coming to you, Joe.
Sir, but
I
you know
soon
what
tell
you
you what it
say?
is, you know. I just want. I just.
Hello?
Sir?
Oh, I see.
Are you hearing me?
Okay, sir, I'm hearing you now.
No,
No, I'm
sir,
saying.
you keep out. We never hear you.
No, Joe was saying that she has a question, so I was answering Joe to say, I soon come. And then no, I was responding to Crosswell to say, Crossy, I soon tell you what it is. What I want to show you is how the formula comes into play. The formula is not difficult, Chanel, as you were saying, to remember because it is so systematic. Let me look at the f double dash. Let me look at the second differential of f of x. The second differential is going to be f double dash of 0 because what you're trying to do is to find the zeros of all the differentials. So if you look at the formula, you can see that a 0 is inside all of them. True or false?
True.
True.
Right. Is Rajay in class now? Somebody just check the participants list for me, please, and tell me if Rajay is in class.
No, he's not.
Okay. All right, let me just pause and say something. This is not just for Rajay alone. At 5:20, 5:30-ish, I recognized that there were like about 8 people, no, 7 because I was the 8th person in class. You see, when you miss these things. I know some of you are at work and joining late, but when you miss these instructions, you are going to be left at a disadvantaged state. And when you don't come class, you are worse disadvantaged. Calculus 2 is not one to play with. You know, if you think Calculus 1 was rough, Calculus 2 is not one to play with. Because it comes with some assumptions that you already know how to differentiate, because Calculus 2 deals with applications. Application to differentiation, which is what we're doing now. When we finish this, I'm going to move to application to integration, and application to integration when we talk about single variable function and multivariable functions. And I'm not going to be reteaching what I did in Calculus 1. Or else I won't finish the syllabus. All right, just say it.
Sir, I'm not reteaching, sir, but if me sit up at time, just I beg you just go by one time. Just one time, sir.
And I don't have a problem with that in my vision. I don't have a problem with that. Where I have a problem, just like what I did a while ago, pause just to refresh your memories. Don't have a problem with that. Where I have an issue is when people don't turn up a class. That's where I have an issue. Class will come. Just like when you turn up, I want to turn up. But you know, let's go. Let's go. So I want you to look at the second differential. We're looking at f double dash of x. We're looking at the second differential. If you look at the second differential, what we're trying to find is a value of the function at 0. You're investigating the differentials at the point x equals 0 every time. Every time. So the second differential is going to be f double dash of 0 over 2 with the exclamation mark. But there's another 2 supposed to be written, x squared. X squared. Let us look at the third differential. F triple dash of 0 over 3 factorial times x cubed. Can you see that?
Sir, can you repeat that, please?
Look at my screen. Look at where I'm spotlighting. That's where I'm at.
Okay, sir.
F triple dash of 0 over x cubed, sorry, over 3 exclamation times x cubed. Let me ask you, Joe, what will be the 9th differential given by?
Sir, if to the 9 over 9 exclamation mark.
No, f to the 9 of 0. Remember, we find the zeros of everything.
Okay.
Continue.
Sir, over 9. The exclamation mark, and then x to the 9.
Excellent, hon. Very nice. Janelle.
Yes, sir.
So you see, it's not difficult. There's some method to it, some similarity to the process. So it's not difficult. All right. Now, what is this exclamation mark? This exclamation mark in mathematics is known as a factorial.
Excitement.
Excitement, yeah. And it is called factorial. You know what the excitement is? So 5 factorial, for argument's sake, is going to be 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the excitement. So I want you now to take note. Take note of my factorial notation. I have to do a factorial notation with you. I call it review of factorial notation. I don't know if you did it in discrete mathematics and algebra. But
yes, I remember something like this.
Yeah, man. So the factorial notation, n factorial.
from 15 years old.
No, well, I can understand you not all. Maybe you're the only one that shouldn't remember. I can understand. So n factorial is really n times n minus 1 times n minus 2 times n minus 3 all the way up to k, and k is going to be a constant. I can't say n because that's where I started. So k there is going to be my constant. So it's like you doing some mathematical induction. You would have done induction already too for discrete math. Hope you remember. So 5 factorial is going to be 5 times 4 times 3 times 2 times 1. Now, if you have a good type calculators and you look at the calculator, you will see the exclamation mark on your calculator. Can you take a minute and identify that exclamation mark on your calculator, please?
Yes, sir.
And that good. And then now, what I want you to do is that exclamation mark on your calculator is known as factorial. So we're not going to call it exclamation mark anymore. It now has a name, and it is called factorial. So what I want you to do is to press 5 and then press the factorial sign and tell me that you get 120 on your calculator.
Yes, sir.
We get 120.
Right. And that 120 is evaluated by multiplying 5 times 4 times 3 times 2 times 1. Evaluate for me on your calculators. Oops, didn't give you any more. That was my question. So this question here is the question I just asked you to do up to the 5th term. But 6 factorial, what is 6 factorial? 720?
Sir, 720.
720, right. Good, so it's going to be 720, all right? So when you evaluate your factorials, it is you multiplying n times n minus 1 times n minus 2 times
Can
n
you
minus
just
3
scroll
all
up
the
a
way
little bit for me, please? Just a little bit. My phone. Just up a little bit more. I want you to finish right now from the formula, sir.
Right here?
Yes, right.
Okay.
I wonder why we have to calculate now with the function, you know, the formula, I should say.
Sir, I don't see that on my calculator, sir.
You remember they said a good type calculator? Which brand are you using?
Sir, I find it. Find it.
It's supposed to be at the top left-hand corner by the x inverse.
Yes, sir, I find it.
Right. Has everybody found the exclamation mark on your calculators?
Yes.
Okay. Is there anybody still looking for the exclamation mark?
Can move on when you're ready.
Okay.
Oh,
All right.
no, so we never finish. What on this, sir?
Chanel, you're so excited. You're so factorial.
So it sounds like I could
I'm
have
gonna need
closed
to
the
write
eye
off.
and still find it.
So I'm gonna need to write off the one on the second one in a pink after take
No, no, you don't have to. Just one up top. Sorry, you're saying something again?
No, so me that say you could have closed the eye and still find factorial. That's how much years you had to do maths.
Yeah. Because once you get it, you don't lose it. You know, it may take a while to come back, but yeah, it does. You won't
Speak
lose
for
it.
yourself.
Let me ask you a question. If you want, well, let me not ask a question. Let me just make a statement. If you once know how to ride a bicycle and you have not ridden a bicycle in years, when you just go back on a bicycle to ride, you may fall or you may feel a little wobbly. But after a while, it will come back to you. Like nowadays.
I believe that application only works where there is interest. Let's put it there.
Not necessarily. No, not necessarily. No, I wouldn't agree with that statement fully. I'm going to tell you why.
So I don't
like many of us learned how to drive using. Okay, but they ignore you now. Like many of us learned to drive using a standard vehicle. Many of us. Some of you may still drive a standard, but some don't drive a standard for many years. Now, if when you go to drive a standard, the car may stall. But after a while, again, you get back into the groove.
That's true.
Yeah. So it's not a fact. It's not matter of where the interest is in terms of the application. You find yourself into a jam, and you better get yourself out of that jam. And getting yourself out of that jam is to go back into your repertoire to do some stuff. So whether or not you like math, you recognize that it's going to come back. Your children may say, "Mommy, Daddy, how do I work this question?" Somebody in your office may be going through something when you finished your studies and say, "Boy, I don't know." You say, "Come here, man. I didn't do this, you know." And it comes back to it comes back to your stuff. Yeah, so I mean, you know, once you learn something, you won't lose it. But it may take a while for you to come back. All right.
Because I can't apply it fast. I never ever can apply it fast.
And that is fine. And that is fine. The race is not for the swift, but it's for those who can endure and endure right.
Do a written exam.
Yeah, man, that's fine. It is fine. And I know, Chanel, you know, the truth of the matter is we had that conversation today. I've had students in the past that were not as quick as other students. But sometimes the ones who are not so quick like the fast students, them end up getting a better grade in the exam than the fast students. You know why? The slow students are very meticulous and they make sure so they want to get something correct. The fast students, they know run through the question, understand what they want to do, but make careless mistakes and lose a lot of marks. So sometimes they end up getting the same grade as the students that are not so fast. So the race is not for the swift, but it's for those who can sit down and endure it right through to the end. So just work with me, man. You should be fine.
Yes, sir.
All right. So now, in 30 minutes, I'm going to show you how to do this stuff. It says expand 1 over x plus 1 up to and including the term x to the 5th power. Now, if I never tell you that part, up to and including the term x to the 5th, the question here will go along. This is one of the functions that will have an infinite differential. Infinite differential. All right, so let me walk you through. Now, you notice what it says? Expand 1 over x plus 1. I must have to first give my function a name. I must give my function a name. Now, mathematics is a language, and we have to speak that language and speak it well. We have to speak the language. So when I name my function, I call it f of x. Then now, I'm going to find f of 0. Remember, we're finding the zeros at each term. So the first thing that I'm going to do is to find f of 0. Anywhere in f of x, I see x, I put 0. Anywhere in f of x, I see x, I put 0. So f of 0 is going to be 1 over 0 plus 1. 0 plus 1 is 1. So I have 1 over 1, which is 1. So see it out here, so f of 0 is 1. Then, sir, why write it so far over there? So you see why. There's a method to my madness. So the first thing I'm going to do is to find f of 0. Look at my function f of x. Anywhere in my function f of x, I see x, I put 0. Anywhere in the function f of x, I see x, I put 0. F of 0 is going to be equals to 1 over 0 plus 1. Which is 1. Then I now need to find f dash of x. I need to find f dash of x, meaning that I need to find the first differential. Remember, the topic is one of application to differentiation. So I'm now going to be finding the first differential of my function. What is my first differential? The denominator, I'm differentiating this function here. Watch me. I'm differentiating this function. 1 over x plus 1. The denominator, right here, times the differentiation of the numerator. The differentiation of a constant is equal to 0. So times 0 minus the numerator minus 1 times the differentiation of the denominator times the differentiation of this, which is 1, all over the denominator squares, which is x plus 1 all squared. So it's the denominator times the differentiation of the numerator, which is 0, minus the numerator minus 1 times the differentiation of the denominator, which is 1, all over the denominator square. When I fix that up, all of this here, x plus 1 times 0 will go to 0. And negative 1 times 1 is negative 1. See it right here, so over my x plus 1 all squared. Remember.
So just go over that again for me, please.
Yes,
Yes,
please.
sir.
Thank you.
Sir.
Yeah, quotient rule you use, sir, for differentiate it. So.
Yeah.
Okay.
You can get the answer. Come
So that's me off up at top.
The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square.
Everybody
So
else
I'm gonna,
complex as this complex.
Yes, sir.
Like for remember all our sir just said a while ago, that not complex.
Yeah, that's right. We put it in the top part, we just label it U and V, and then we say differentiate U, differentiate V, and crisscross it. That's how we do it now.
Crisscross.
Confusing. Yeah, nobody follow me. Me a madman. We find ways to make my madness work.
That's true. We have practiced from last from calculus 1. That's why it not come off hard to us, you know. But you know, if you take a break from it.
What? Long break.
Long break. When we get plus one vision?
You can't remember years.
I just,
From 2021.
yeah, I get it when you start do a few more questions or a few more homework, so I'm sorry. So don't worry. Yeah.
I continue.
Like, sir, Wi-Fi now making
Yeah,
continue.
man, it only comes with practice, you know. Is it everything right here, so? It comes with practice. You had to learn it, me have to learn it, and others who went ahead before you had to learn it, and those who are coming up behind you are going to learn it. Hold on. Here. That's what me on no behavior. I'm sorry, but flow not going too good at all. Are you guys hearing me?
Yes, sir. We're hearing
Yes, sir.
If I tell you that I'm using two devices with two different internet access, one being digital and one being flow, I really want let me disconnect one of them. I really want you to believe me.
Sir,
Yeah,
so you hearing me? Right?
yeah.
Oh, I was just, yeah, because I was saying something before you weren't here. So when you bring it back up though.
No problem. Yeah, so I'm using two different devices, two different internet access, and trust me, every time the flow goes down, the digital one goes down as well. So I hope you listen to what Tariq was saying. And I'm going to say to you, it comes with practice. Last year we did some DJs or DJing in class. And one of them is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squared. None of those of you that were with me for calculus 1 cannot say to me that you not catch that one day yet, or member of it, because that's something that's supposed to be etched in your headspace. Now I understand those who took a long sabbatical and now coming back in. There are other methods to do it. So the method that I'm talking about, the U and the V, that's the method that I was taught many years ago. But when I was introduced to this other method, which is the same method, incidentally, if you look at it. This one here now, I don't have to go say, what is U again and what is V? You just look on the question and say denominator. Boom, write it back. Times the differentiation of the numerator. I mean, most of them look on the numerator and differentiate that. And we do that. Minus the numerator. Boom, write down the minus sign and write it where the numerator equal to. And then we will differentiate the denominator of this. Times the differentiation of the denominator. Write it back. And then we will say boom over the denominator squares. And sir said, never ever ever try to expand the denominator. We not do it. We won't expand the denominator, but we'll leave it as a product like this. So a square term. We not expand it. Because turn right this up. So let's go in 2 minutes. It's the denominator right here. Oh, sorry, I need to spotlight again. It's the denominator, x plus 1, times the differentiation of the numerator, 0, minus the numerator, -1, times the differentiation of the denominator. When I differentiate x plus 1, I'm going to get 1, so it's times 1. When you see this, please do not read it as minus 1.1. No.
-1 times 1.
let me show you what 1.1 looks like. You see where the point is for 1.1 at the bottom. Where's the point right here, so?
In the middle. Sir.
In the middle. All right. Yes,
Yes,
let's
sir.
crossword. Let's go ahead, sir.
Why is it so why is it that we're using an alternative arithmetic symbol right now?
Because we are a big school. We are a big school, that's why. Big school. When you reach a foreign, you no longer eat certain stuff. You eat calamari and swims.
Sorry?
Yeah. Big school. The point I'm making is we're changing. It's pretty much the same thing, but what we're looking at is just a notation. We don't want at this level to go right no multiplication sign. That's for lower level.
Sir.
Sorry, the alternative arithmetic symbols for the other functions.
If you feel comfortable writing a multiplication sign, go right ahead and write it.
No.
Right, but me know that that means multiply, but at the sign
I normally write my multiple.
So that's not what I'm asking. I'm asking there's alternative symbols. So like say the other arithmetic functions like addition and subtraction. Just multiplication.
Yeah. Well, of course, you know that they have alternative for division, because division I can write a stroke like so and call it division, right here, so? Sometimes you see the stroke right here, so don't.
Yes.
Or we can write the stroke straight across, so don't. Or we can write the division sign with one stroke across.
Sorry for interrupting. I have to go. You're gonna send this video tonight. I miss about 10 minutes of this. My internet is really.
Yeah, my one is messing up too. I keep going in and out.
Don't hear not where you do here, so.
All right,
but
no worry about it. Yeah, no worry about it. All right, so yes, Crosswell. So I have different ways that I can represent my division. I can write the good old division sign with the cross and the two dots up top, and I can write it like that. But yeah, but anyhow, not to take away from it. So I'm going to end up with f dash of x is equals to -1 over x plus 1 all square, and then I'm going to find the 0 to this. So anywhere in the differential I see x I put 0.
Wait, oh, we get the all squared.
Over the denominator square.
Why we square it?
As we said, quotient rule. So I stress out my brain now, the quotient rule.
The quotient, what?
Yeah. So the v squared, when I do the quotient rule, v squared.
Oh, the denominator must be squared. That's a rule.
Yeah. Yeah.
All right.
So that's just what my brain.
And then now, what we're going to do, anywhere in the differential we see x, we put 0. So you have -1 over 0 plus 1, which is 1, and 1 squared is 1. So -1 divided by 1 is -1. I'm going to have a -1 right here. So, and that's where I'm going to pause for tonight and just say two things to you. Thing number one, we have to turn up on time for class.
Well, yes, sir.
Thing number two, we have to do a lot of revision on our differentiation and our integration, because this course deals a lot with applications to differentiation and integration. All right, go ahead with your questions, and then we'll close off.
All right, sir. For EducaSoft, the first 30 questions was a test or quiz, but I remember what you said. Is on these topics or what goes about on EducaSoft?
I'd have to go back and look there. I don't want to answer you and misinform you.
Okay.
Let me go back and look at it, and then I'll let you know.
So, point again, sir. EducaSoft, you pass the information. Are all information?
On my group, him send the notes at that.
No, like any information at all.
The outline the for EducaSoft. That alone, me say.
I don't have access to that up there, sir.
You do, but I recognize you have not logged on.
Log on, where, sir? What does it mean, log on?
I recognize that you have not logged on, and you're going to be in problems, sir. Because if you get an A for the exam and you don't do your EducaSoft pieces, you're not going to even pass the course.
Jesus, all right, Because hold on your turn.
So you are there. Your username is your email address. And your password is default password is welcome. So you are there.
Later.
But anyhow, peace and salutations. Come tomorrow ready to finish off this question. Is tomorrow?
Can come a
Yes,
class
sir,
tomorrow, sir, because I can notice.
Yes, sir.
I'll know when I reach our Wednesday class because I never get home by time. It's
So you may need to do like what Lotto do. When the class go come in on the travel time, you stay back a little bit so you can at least get the class.
but that's what I'm saying. So I'm gonna catch P-site. Anyway, I'm taking me to catch P-site only. I mean,
All right, then.
that work. I mean, I think that worked for maths for me.
All right, never mind.
But now I go
Peace
catch.
out.
That's why I that we want the recording. But me I go try it for tomorrow too.
All right, peace and thanks. I'm really depending on you for that. All right, guys, all the best. Go to your next class now. Guys, what 7:05.
Sir, we have to do something about Edeka, sir.
Somebody answer him for me, please.
It's mandatory.
Yeah.
Because
Yeah,
for bread and butter.
When I do them, starts giving me it's delaying me. Each time I doing it, it's telling me that I don't complete something. But then it takes so long. It's when I go back in it update since night. So that's why I never even bother send up more.
So when we are going group up and do it, we don't feel like
Have a good night. Have a good night. Don't follow Bushon here. Have a good night, your students.
Sir,
Good night, sir.
I only for degree I give you, I think I won.
Have a nice night.
Bye. Good night, everyone.
Good night. Good night.